Welcome, everyone. Thanks for joining us for Technical Talks, our monthly webinar series. We've been doing it for a little over 3 years now, and we're blessed to have a lot of good presenters with us. I'll introduce today's guest speaker here in just a few minutes, but it's Nathan Ivey, and I will introduce him in a minute. But Nathan, I noticed when I took your headshot and I put it on this title slide, it looks like you're looking at me lovingly, which is pretty good for you. We've never met in person, but I really think those pictures go great together. I'll give you a chance to defend yourself here in a few minutes. But folks, I am glad you're with us. Just a brief recap here for those who are new to our webinar series. I am the civil engineer for Hale Holdings Company. We have ASP Enterprises, Quick Supply Company, Bowman Construction Supply, Cascade Geosynthetics, and Hale Holdings runs a number of other businesses, family owned right here in the center of America. We do have a lot of years, decades of experience in the construction site supply industry. And we have a number of dozens of salespeople across our markets who are experts at what they do. My job is to help them technically with a handful of engineered products and some challenging sites, and then growing our relationships. But we also are blessed with a lot of wonderful people in logistics at our warehouses and our trucking and in our accounting department. These are the states we cover with our 4 families within Hale Holdings. A number of offices in each of those locations. We have 10 offices. We even have some other remote folks working in some other areas. These are where we focus most of our efforts. Most of you viewers are in that, somewhere in that map, but some of you are outside of that. We're blessed to be in an industry where we're friends with a lot of people and information is readily available. In addition to our engineered products, we have a lot of the typical erosion control and sediment control solutions, geosynthetics. I spend most of my time helping with stormwater management, green infrastructure, but it all bleeds over to vegetation projects or some repair projects. We have hardscapes divisions at some of our locations as well. So a diverse company with a lot of talented people. This is what kept us humming through the pandemic, and we haven't slowed down. We're very good at taking in large quantities of materials from manufacturers and then strategically and surgically delivering those materials when and where our contractors need them. That's one of the places we add value. Whoops. Okay, I guess I jumped to it. Oh, yeah, here it is. Here's a team that I'm very proud of. So when I go to each of those locations, I obviously meet with the sales team inside and outside, but I make it a point to go into our warehouses, into our yards, and to meet our drivers and our warehouse operators. We're blessed with the best. And with that, I'm going to hand it over to my new friend, Nathan. Let me see. I might have to send controls again. If you click on it, you might be able to advance it. This is your first slide, Nathan.
All right.
Other than your handsome headshot, I didn't give a bio of you, other than I do remember you're a Texas A&M Aggie. So I know you come from a school that appreciates a good bonfire, which I do too. I live out in the country, but you're also an engineer. And when I describe being technical support for my company, you're technical support for your company and my company, correct?
Right. Yes, I'm the technical manager for concrete canvas for our U.S. operations. I've been in the geosynthetics industry for going on 30 years. Spent a lot of time with GSE before it became Solmax, and then with Agro for a while as well. I've been with concrete canvas for about 2 years now.
Awesome. Well, if you click on that slide, I think you're going to advance them. I'll mute myself, but I'll chime in periodically. How about that?
All right.
There you go, buddy. Thank you.
So I'm going to start with a brief introduction to GCCMs, how they got started, a little bit of history, where you can use them, talk about some design considerations, some ASTM test methods that are available to help you specify the right product for the right project. I'm going to go through some applications and case studies and close out with some installation considerations and benefits. So we get asked a lot, how did concrete canvas come to be? Well, back in 2004, our owners were in college and they developed GCCMs for a rapidly deployable shelter that could be used as an emergency hospital, emergency shelter, those type of things. It was comprised of a GCCM. It's shipped out on a pallet. It's inflated. It's hydrated. It's pegged down. It's got a door on both sides and can become an emergency shelter. About 5 years later, we got into commercial production of GCCMs under the name Concrete Canvas for use on erosion control applications. Since then, we've worked with ASTM, with GRI to develop test methods, make sure the test methods make sense, make sure that they are repeatable and reproducible. Dr. George Kerner has done a lot of work with AG material, also with conducting tests and helping us to develop new test methods for GCCMs. So ASTM defined the GCCM, Geosynthetic Cementitious Composite Mat, as a factory-assembled geosynthetic composite consisting of a cementitious material contained within a layer or layers of geosynthetic materials that becomes hardened when hydrated. Our tagline is concrete on a roll because it's a geosynthetic containing concrete that can be rolled up. In that top photograph, you can see what we call a bulk roll that weighs about 3,400 pounds. It's a hard armor solution, so it can be used anywhere where either you don't want to mess with maintaining vegetation or areas where you can't get vegetation to grow. So it's absolutely a hard armor solution. However, it's a very thin veneer of concrete, so it can't be used for driveways, sidewalks, or anywhere where there's daily traffic. Low ground pressure vehicles such as ATVs, that type of thing is okay, but it really can't be used for driveways and sidewalks. This is a graphic of our original product. It's a three-dimensional fabric matrix that's filled with cement. It has a PVC coating on the back. The PVC coating performs three functions. Number one, it keeps the concrete in place during installation. Number two, it helps control the water to cement ratio during hydration and curing. And number three, it prevents permeation of water or other fluids through the plane of the GCCM after it's hardened. We all know that concrete is a fairly porous media, so without that PVC or other LLDP backing on the back of the GCCM, water would still be able to go through it. So again, when and why hard armor? When soft armor protection won't work, again, lack of vegetation. A hard armor solution is typically where you want to have a hardness resistance, you want to have good durability, good chemical resistance, and good impermeability. Aging studies have indicated about a 120-year lifespan for concrete canvas when used in an erosion control application. In a canal application, it's going to be less than that. Testing goes out to at least 50 years right now, but that's somewhat dependent upon velocity of water flow, turbidity, abrasion requirements, and things that are associated with site-specific channel conditions. It can be used to replace cast-in-place concrete, shotcrete, other types of liner systems where there'd be a concrete over a membrane, conventional stone and riprap, filled geowebs, articulated concrete blocks, pumped concrete mats, that type thing. Again, so this is a photograph where they try to use a vegetated armor, and you can see the wave action just destroyed it after a while. So when you're choosing the right material for an erosion control application, it's important that you consider all of the variables. If you do want a vegetated solution, are you going to be able to get vegetation to grow? Will that material last long term? Is the water brackish or salt water such that it won't support vegetation? This is a graphic that just sort of details all the places a GCCM can be used. Starting on the left-hand side, bank protection. Not in an oceanic condition where it's subject to severe wave actions, but rivers, streams, ponds, lakes, that type of thing, it can be used for bank protection. It can be used to remediate existing concrete structures. If you have a concrete lined canal that is cracked or seeping, you're losing water flow through that concrete channel, you can line over it with a concrete canvas, and because it's thin, you retain your water volume flow characteristics without compromising any of that. It can be used to remediate existing culverts. If you have a culvert that is still structurally sound but is starting to pit out or rust out in the bottom, you can line that with the concrete canvas, and again, the PVC backing layer prevents water from penetrating through it, so the bottom of the culvert isn't sitting in the water the whole time, and it can extend the lifespan of these culverts by anywhere from 5 to 15 years or more. We have seen solutions where it's been in place for 10 to 12 years and is still working, so we feel confident to get at least 10 years out of it, potentially more, but again, It depends on the abrasion characteristics, the water flow volume, and how often water flows through it. Going back up on the photograph, slope protection is the next application. So while concrete canvas is not a slope stabilization product, if you can stabilize a geotechnically unstable slope using earth percussion anchors, for example, then the concrete canvas could be used to protect that now stable slope from erosion. Or if you have an existing slope that is geotechnically stable, it can also be used for erosion control in that application. It can be used for weed suppression underneath gates, fences, pipe tracks, for lagoons, for containment applications, and also for berms around storage tank facilities, for example. And I'll have some photos.
Don't click yet. Wait, you know I love this graphic. I'm sorry to interrupt you, but
That's
I
right.
told you I love this graphic. And when you show weed suppression under that fence, remember the one I brought up was a cable barrier for DOTs. I think there's going to be a big market for that. It may not happen yet, but thanks for letting me interrupt you because I love this graphic. And
Yeah, sure.
I think it really tells a story. I'll let you keep rolling, buddy.
All right. Next, I want to talk about ASTM test standards, specifically ASTM D8364. So prior to GCCMs, there were a lot of existing ASTM test standards that could be used to test thickness, density, mass, that type thing. But there were also a lot of tests that were specific to the GCCM because there aren't any other geosynthetics currently that start off soft, that end up hard, that need to be tested in tension and compression. So a lot of these test methods had to be developed specifically for GCCMs. D8030 is a standard practice for sample prep. So this guarantees that all laboratories prepare their samples the same way. They hydrate them the same way. They hydrate them for the same amount of time before they perform their testing. 8058 was a brand new test method, the 3-point bending test. I'll show that in just a little bit too. That test both the tension of the geosynthetic plus the compressive strength of the cement component. 8173 is a standard guide for site prep and installation and hydration. Again, it was a relatively new class of geosynthetics. There were a lot of people that weren't familiar with how you do prepare the site, how do you join it, how do you overlap it. So this is a standard guide that kind of gives you some of the basics for installing the material. And D8329 was a new test method that was developed for determining the compressive strength for GCCMs. All the existing test methods for testing compressive strength of concrete revolved around using the optimum amount of water in the concrete mix. And I'll discuss this a little bit further as well, but 8329 was developed for GCCMs. Within ASTM D8364, they list 3 types, type 1, type 2, and type 3. They list minimum test frequencies, minimum test values for each of these 3 types of products. They also give typical applications for each of these 3 types of products. Type 1 is the thinnest, so it's got the lowest requirements for abrasion and wear. And it's recommended for slope protection, weed suppression, remediating of existing concrete structures, for example. Type 2 is for greater requirements of abrasion and wear, where you have higher shear stresses, maybe higher flow velocities, maybe poorer subgrade soil conditions. Also for culvert remediation, type 2 is recommended. Type 3 is the thickest, strongest, where you have potential for damage, severe conditions. The photograph on the bottom right, you can see there's a rock in the bottom down there. So if you have the propensity for rocks or trees or large animals to potentially get in and damage your application, then you could use the type 3. Not every client always uses the type that's recommended in ASTM 8364. I've seen type 1 used for canals, for example. I've seen type 1 used for culvert remediation, for example. As long as you have the right soil conditions, the right flow conditions, the type 1 can work in some of those applications. So again, these are guidelines. It's not necessarily a rule that you have to use what ASTM says for each of the specific applications. This is the table of type 1, type 2, and type 3. I know it's kind of small, but you can sort of get a gist of what tests are required, what values are required for each of the different products. Concrete canvas is the only GCCM that does meet or exceed all specifications in ASTM D8364. There are some Me Too products out there that promote themselves as being GCCMs, but maybe they're lacking a polymer coating on the back. In all cases that I'm aware of, none of them meet or exceed all requirements of the ASTM. So when you're specifying products, you don't necessarily have to say concrete canvas, but you do absolutely need to say that it's going to meet the requirements of ASTM D8364 because it is the only internationally recognized standard for GCCMs. There is no GRI test standard like GM13 and 17 for geomembranes. This is the only standardized specification that has been universally accepted and approved for GCCMs. Compressive strength is one of the big things for a GCCM. The concrete in it has to be strong. The blue bars indicate what our compressive strengths are for type 1, type 2, and type 3. The red lines indicate the ASTM minimums. So you can see that our type 2 GCCM almost meets the compressive strength for a type 3 in ASTM. So our compressive strength is very high, higher than it has to be. And this is using ASTM D8329 to determine the compressive strength. So what 8329 does is instead of determining what the optimum water to cement ratio is, it requires that you first test an unhydrated specimen of GCCM, then you hydrate that specimen of GCCM, and you measure how much water that GCCM absorbed when completely submerged underwater. Because as this graph shows, high water to cement ratios can give you artificially weak compressive strength. Low water to cement ratios can give you artificially high water to cement, artificially high compressive strength. And again, ASTM C109 has always been used historically using the optimum water to cement ratio. And since in any application of a GCCM, there are bound to be some areas of the installation that does in fact remain underwater for the first 24 hours. This test method was to develop the compressive strength of the cement in the worst case condition. Another test method that was developed specifically for GCCMs was 8058, the 3-point bending test or the flexural strength test. Again, the geosynthetic component is strong in tension, weak in compression. The concrete component is strong in compression, but weak in tension. And again, there wasn't a single test that could test both of these at once. So the 3-point bending test was developed so that we can test not only how strong is the compressive strength of the cement component, but how strong is the tension component of the geotextile portion. This is just sort of a graph of that. You see the bar coming down, testing the load and the compressive strength of the concrete and the tension of the geosynthetics. These are a couple of photographs of that actual test being performed. The top photograph is when you first put this test specimen in. The two bars on the right and left are both fixed. The one in the middle is moving downward. The second photograph shows when the concrete component first starts to crack. That's what we report as the initial crack or the first crack. And then you continue to move the bar all the way down until the geotextile components are absolutely separate as well. And that's determined by, that's called the final flexural strength.
I nerd out on this one. So Nathan, I didn't interrupt you when we were practicing on this one, but I took a strength and materials course at engineering college, and I did great in the lab. I was not a very good student. I didn't get great grades, I'll be honest, but I was great in the lab because I loved this kind of stuff. And I know the previous slide showed the compression versus tension, but the video of this, and talk about videos, I mentioned that our company, Madeline, does a great job of posting these videos to YouTube. Your company has great videos too of the different applications and the testing. So some people kind of get lost and they glaze over when we talk about ASTM and the D8364, which is important, 8329, this 8058-19. They're all important, but a series of pictures and a video really tells the story. So this right here, I love this one. This is what sets apart you from the Me Too's, is that performance spec for sure.
Yeah,
Thanks
thank you.
for
And we do have dozens of videos on our YouTube channel. We got some on our website. It shows not only the testing, but also shows installation. There's some installation training videos on there if you're just unfamiliar with it and want to sort of get a feel of what it looks like when it's being installed. I think there's a time trial on there showing you how quickly it can be installed. So we do have an incredible amount of technical information on our YouTube channel for
Thanks
sure.
for being a good sport. You're a pro.
Thanks. Okay, now I want to go through a couple of different case histories and just show you. I talked about the main applications where it's used, canals, slope protection, berms, culverts. Now I want to show you some actual examples of some of these project applications. Now this is just random photographs of different applications: erosion control, channel lining, slope protection, concrete remediation, and so on. Just a handful of samples of what finished projects might look like. The first case history is in Maxwell Air Force Base in 21. This was a channel application. On the left-hand photograph, you can see they've installed some geotextile and some gravel as sort of a French drain or an under drain system. This can also be used in conjunction with a geonet, geocomposite, a piping system. So if you do have high groundwater pressure, you do absolutely have to address that, but there are a myriad of ways that you can tackle that. The right-hand photograph, you can see the materials being installed. It's anchored in the anchor trenches on both edges. They're screwing it together with stainless steel screws on 4-inch centers. This application, they're also using adhesive to get the permeability down between those joints, and I'll talk about that in just a little bit as well. So for a typical channel application, number one, you do absolutely have to have an anchor trench on both sides. You also have to secure it at the ingress and egress. You don't want wind and water getting up underneath the concrete canvas, which could cause erosion that you might not see until it was too late to fix it. Furthermore, within the anchor trenches, you'll use a J-peg or a twist anchor or something to peg the material down every 3 foot within that anchor trench. Again, that's mainly to keep the material in place until such time as that anchor trench can get backfilled. Just to ensure intimate contact with the bottom of the anchor trench. Typical anchor trench is going to be 6 inches by 6 inches. We also have installation guides, whether it's slope protection, channel protection, culverts, or other that are specific to each of those application families. And the slope protection, we talked about potentially using intermediate anchors or deeper anchor trenches if you do have slopes that are more than 10 foot long. Up to about a 20-foot length slope, you can mitigate that by going up to a 12 or 14-inch anchor trench. But 6 by 6 is typical and normal. Intermediate anchors, we have a hydraulic calculator that we can use for you or send to you for you to enter your data, whereby you enter the friction angle of the soil, the slope depth, the slope angle, the channel slope, and the depth of the water within that channel. And we can help you determine if you do need intermediate anchors. It's fairly rare that they are required, but there absolutely are some places where they are needed. Or if an engineer specifically says he wants them or she wants them, then they also need to be used in those applications as well. As far as attaching to existing concrete, we have PDF and AutoCAD details that we'll happy to share with you, showing you how to attach it to existing concrete. You can do like they did here and get it as close as you can and then grout in that space. You could have turned it up and used the batten bar or concrete anchor bolts with washers, or you could have poured concrete in an anchor trench right there. So there's a variety of ways that you can attach it to existing concrete. But again, because it is concrete itself, any of the ways you would join traditional concrete, you can also join this material. Photograph on the right, you can see it being hydrated from a water truck. We do recommend normally you would go over the entire installation with water, wait 30 minutes to an hour, and then go back over it again. The important part here is you can't overhydrate it. Even if the material is underwater for the first 24 hours, it will still cure as expected. If you underhydrate it, there's a potential that the top layer could become hardened and cured and leave some unhardened material between the hardened layer and the underlying geosynthetic. So it is very imperative that you do hydrate it fully, that you don't just depend on rainfall or snowfall to hydrate it, but that you do actively hydrate it with the water truck. This is what the finished application looks like. At the far end of this photograph was that culvert where they were tying into. They haven't backfilled the anchor trenches yet, but the material has been hydrated and has been hardened. Next application I want to talk about is a berm application for secondary containment. This is a tank farm in, I believe it was Iowa, where they had grass or vegetated berms that they were having to maintain. They were having to mow the grass, feed the grass, water the grass. So they wanted to use a concrete canvas to line those berms so they could get rid of all those maintenance considerations and also not risk those slopes eroding over time. So the photograph on the left, you can see they got the anchor trench at the crest and the toe. At the crest, it looks like they're going to just use concrete. I think they did that so that they can mow right up to the edge of the concrete without worrying about damaging the concrete canvas. At the toe of the slope, they used, looks like just pea gravel. But again, it does have to be anchored top and bottom to prevent wind and water ingress. This is an aerial photograph where you can see what the tank farm looks like. Again, prior to the ones that are white now because they were lined with concrete canvas, they were all vegetated berms, and they were just spending a lot of money and a lot of time maintaining those berms. So that was the reason they decided to go on with the concrete canvas. Next application I want to talk about briefly is scour protection. They were getting a lot of scour on the side of this head wall during heavy rain events when water would come off the road and just go down right side by that culvert. So what they did was they put a piece of concrete canvas right there. They put riprap at the bottom. They just mechanically attached it to that existing steel wall. A couple of weeks later, they got a pretty heavy rain. The area flooded. After the water receded, the concrete canvas was still there. There wasn't any scour. So as a result of this pilot program working out so well, they went back into the other three sides of the culvert so that none of it would scour anymore. Another advantage of the concrete canvas is that it's eco-friendly. I've talked about subgrade preparation. You can see in this application, they wanted it to sort of blend into the natural surroundings. So they didn't do it as great as a flat, smooth concrete surface. They left it somewhat rough with some undulations in there. And you can see this photograph was taken 3 years later. It does support the growth of moss, algae, other very shallow root system plants on top of it. So while material will not grow through it, it can blend into the natural environment over time and look almost natural. This is a slope protection application that we did on a landfill in South Carolina. Their existing slope wall was failing. You can see in the photographs, the two photographs on the left. So they went right over that existing wall with a concrete canvas. Again, secured the top and the bottom with riprap in this example. Had a swale down at the bottom to handle the water runoff from that slope. This was installed in 2012. We did go back out there last year, so a little over 10 years later, the material was still there, still in place, and the client was still very happy with the way it was performing, more than 10 years later. Next application is remediating existing concrete structures. This was a Caltrans project in Olivehurst, California. Top left photograph, you can see the condition of the existing concrete canal. It was cracked. They were losing a lot of water to seepage over time. So again, they went back with the thinnest, the type 1 concrete canvas right over the existing concrete, anchored it in the anchor trenches, and again, restored it to as new conditions. There was no more water loss after they remediated the existing structure. This was a drainage ditch in Colorado that we did last year for the DOT over there. This was, they were having a lot of erosion from water draining off the highway down to the road below. So what they did on this one is they put actually sandbags underneath the concrete canvas to make baffles so the water wouldn't necessarily shoot right down the slope, but that would sort of break up the water flow. You can use sandbags, you can use jersey barriers, you can use concrete bags. The concrete canvas will conform to what the subgrade looks like. So if you want it to be rough and uneven to slow down water flow, then you can install it over that, and that's what it will look like. If you want it to be perfectly flat and smooth, like in a berm application, then as long as the subgrade is prepared properly, then the finished product will also look flat and smooth. This was one that we installed in 2017 in New Orleans for the Flood Protection Authority. We went out there last year as well and took some photographs of this, just as sort of a 5-year aging case study. And as you can see, it's in New Orleans, so it's probably been underwater a couple of times since 2017. But the canvas is still there. It's still diverting water off the road and still performing as they expected it to. The last application I want to touch on, I'm sorry, this is slope protection again. So we've been asked, can it be used on vertical walls and vertical slopes? Yes, it can. In the photograph on the left, if you look closely, you can see there are some earth percussion anchors holding that material to the slope. I'm sure they use a deeper anchor trench as well. But yes, the material can be used on vertical slopes. There may be some additional considerations for anchoring it to that slope, but it can be used. The slope on the right, while not vertical, is still quite steep. This was another application where it was used for slope protection. The last application is culvert remediation. So again, it can be used to remediate existing culverts as long as that culvert is structurally sound. So it can be rusted, it can be pitted, but it can't be pancaked, it can't be, oval. It needs to be still structurally secure. You would lay the concrete canvas in the bottom of the culvert, like in the photograph on the right, seal along the edges, such that the water can't get back in behind it if it were to be full for some reason. Then attach it to the existing culvert with sheet metal screws and washers. And again, get 5, 10, 15 years out of your culvert without having to replace it. Next, I want to talk a little bit more about some insulation and some benefits of concrete canvases, particularly as it relates to conventional materials. So we compete with riprap, pour-in-place concrete, shotcrete, fabric formed concrete, pumped grout mattresses, those type things for erosion control applications specifically. In almost every case, the concrete canvas is installed faster with less complexity, lower skill levels required, and much higher output. One roll of concrete canvas weighs about 3,500 pounds, but it's 558 foot long, 3 foot wide. All you really need to install it in most applications is a forklift to lift it, a razor knife to cut it, and then a drill to screw it together. So there's no forms, there's no rebar, there's no cement trucks coming in, there's no grout trucks coming in. I did 6 or 8 projects last year with existing crews that were either maintenance crews for a plant, perhaps they were city or county workers. I would go out there for a day or two to get them started on the project. I would leave and then they would finish it up. Did a couple of those this year as well. So it's very easy to use, very easy to learn how to install properly. And it's also very easy to get into difficult to access locations. We have what we call batch rolls, which are rolls that weigh about 150 pounds that 2 people can carry. If you have a difficult access area, if you have a small project, if you have a repair of some sort, you can get these in just about anywhere. Now, concerning installation, all panels are overlapped by 4 inches in every case. They're typically joined together at 4-inch or 8-inch centers. 8-inch for the northern half of the U.S., 4-inch for the southern half of the U.S. This is probably how 70 to 80% of material is installed, is just with the screw. spacing of 4 or 8 inches. No welding, no bonding, no adhesive sealant. So while this is not an impermeable joint, it does prevent slope. It does work for slope and erosion control. It does work for canals if water is flowing over the seam. If you have a canal application where water is going to be sitting in there for long periods of time, then you might want to go ahead and use the sealant as well. So the sealant is going to give you a higher level of impermeability. The way this works, you still overlap at 4 inches. You lay down the bead of sealant before you install the screws through that bead of sealant. So it does increase the tensile strength of that seam, and it does decrease the permeability of that seam. The strongest, most least permeable seam that is possible is thermal bonding. And this application, you use an automated hot air welder to melt the backing of the PVC to the top of the polyester geotextile to get a seam that is very low permeability and also very strong. No screws are required, no sealant is required. The only thing about this is now you've got to the point where you do need a specialized piece of equipment. You do need someone who is well skilled at hot air welding to ensure proper speed, temperature, pressure to make sure you do get a good weld between those two layers. The benefits over traditional methods, again, installed up to 10 times faster than conventional concrete. Three or four people out there can install, thousands of square feet in a day. Minimal training required. Again, we do have videos that are available. We can come to the site for a couple of days to get you started to kick off the installation. Material savings of up to 90%. Lower CO2 than conventional concrete, up to 65% less than what a traditional concrete project would have. In fact, one bulk roll of concrete canvas is equivalent to two 17-ton trucks of a traditional 6-inch pour-in-place project. So a lot lower carbon footprint. Less vehicle movement, especially in petrochemical facilities in Houston. It's a lot easier to get a bulk roll of concrete canvas onto a job site than it is to get 2 cement trucks. So a lot less moving parts, a lot less equipment, and a much quicker installation.
And a lot less logistics. Just to chime in on that, we've had some experience with some pavement projects in the past, and you're adding another layer or two of a company that makes the product and a company that can truck it and hopefully get it there at just the right time.
That's right. Yeah, the logistics are a nightmare because you got, like you said, the cement truck, the form guy, the rebar guy, all those people have to come to site to do their part of the project.
Yeah, thanks for letting me chime in.
Yeah, sure. This is just sort of a typical, what concrete canvas versus conventional concrete might cost and how long it might take. So the concrete canvas, 2 installers, 1 operator. So 24 labor hours per day. It's going to take you a couple of days to finish it. Traditional concrete, it's going to take, delivery drivers, your cement truck drivers, your pump truck drivers, your steel, your rebar, your forms, your placers, your finishers. So where the concrete canvas project could take 2 or 3 days, the pour in place could take 6 or 7 days. Cost-wise, it's almost always cheaper to use concrete canvas than conventional pour in place. Obviously, if you have a cement plant right across the street from your project, maybe it'll be closer to the $8 number, which would be competitive. But if you have to truck your concrete any distance, you're looking more like $12 to $14 to $15 per square foot versus about $6 to $9 a square foot installed for a concrete canvas. The next thing I want to touch on are our installation principles. We have 4 of them. Number 1 is avoid voids. It's pretty straightforward. You need to make sure there's no rocks, no tree stumps, nothing that could damage the underside of the GCCM to compromise that PVC layer. If there's any void spaces, they need to be less than 2 inches. If it's an existing concrete remediation project and there's chunks of concrete, you have to remove those, patch those areas before you start with the installation. And it's not that this void space is going to hurt the concrete canvas, but if it's unsupported, then it's going to be prone to damage in the future, whether a rock falls on it, an animal steps on it, somebody drops a tool, or somebody steps on it. So it's very important that there be no voids and the entire subgrade be supporting the concrete canvas. The second one is to secure. Again, there's 3 ways to secure it far and away. The screw joint is used, screwed and sealed joint. If the screw joint is 70–80%, the screw and seal is probably 10–15%, and the thermal bonding is 5% or so. I've rarely seen that down on concrete canvas. Prevent infiltration. Again, you do have to have anchor trenches. You do have to have the material pegged within those anchor trenches. They do need to be at least 6 inches by 6 inches, maybe deeper. Maybe earth percussion anchors are required depending upon your site-specific conditions. But the material does need to be anchored and secured to prevent infiltration. The last is to hydrate fully. You can't rely on rainfall. You do have to actively hydrate it. The water doesn't have to be drinking water. It doesn't even have to be potable water. It can be brackish. It can be seawater. As long as the pH is at least 6, it can be used to hydrate concrete canvas. You don't want to use a high pressure jet because you don't want to displace the concrete powder from the GCCM before it has a chance to set up. So whether it's a spray hose or a water truck, or like this guy is using here, just a healthy flow of water, hit it once, come back 30 minutes to an hour, hit it again. If it's very hot, if it's very windy, if it's very dry, you may have to hydrate it 3 times, not just 2. So there is a little bit of things that are site specific as far as how much you do have to hydrate it, but typically at least twice. We say about 40% of the weight of the product in water. The type 1 weighs about 1.5 pounds a square foot. So that means for a gallon of water, you would get 13 or 14 square foot hydrated out of that gallon of water. Just a rule of thumb of how much water you would need. The last thing I want to talk about is one of our newest product developments, which is CCX. It's designed for water convenience applications. The reason we developed this product was in part due to a study that the USBR did back in 2002, where they determined that a geomembrane with a concrete cover was the absolute best product for durability, maintenance costs, and seepage reduction for canal applications. So CCX is a type 2 GCCM used for water convenience applications, whether it's an existing ditch remediation or whether it's a new irrigation canal. CCXM can be used for this application. This consists of a 12 mil LLDPE backing rather than a PVC backing. This also has 2 geotextiles, which are stitched together, and then that interstitial space is filled with cement. So it's a little different manufacturing process than our original product. This material can be installed just like regular concrete canvas. Joints can be screwed only. They can be screwed with sealant, or we can actually thermally bond them in conjunction with screws to get permeability on the range of 5 to the -8 meters per second. This is our data sheet for our CCXM. You can see that our values in the table are higher, and in many cases significantly higher than what ASTM requires for a type 2 GCCM. Compressive strength requirement is only 7,200 pounds. We're over 10,000 PSI. Brake load, we're again almost double the requirement of 8.5 pounds per inch. Flexural strength, we're nearly 3 times the requirement of 580 PSI. So again, very, very good numbers for the CCX product. I just want to close out with a couple of applications of where this has been used. This was one of our first projects in South Africa in 2020. We were first working to develop the product. This is a 165-foot channel, about 7 foot wide. Again, they had an existing concrete channel. They were losing a lot of water flow through seepage and water loss, up to 60% in fact. So we went back over this initial test section, to see if it would improve, and it virtually eliminated all water loss in this section. This was another one in Chile about a year later. Again, the same thing. They had a 260 foot canal, about 10 foot wide, where they were losing a significant amount of water with their existing irrigation canal. So we relined, this 260 foot channel section and virtually eliminated all water loss for them as well. The next one is a project that I installed or that I helped install in December of last year. This was in Lynn Haven, Florida. This was a drainage ditch in a residential area. What would happen is every time it would rain, the channel would silt up such that they had to come out with trucks to scoop out the dirt, haul off the dirt, and reprofile that channel. So they went in with the GCCM, so that now if there is any sand or dirt that gets in the channel as a result of a heavy rain event, they can just wash it out with some water. They don't have to get out the heavy earth moving equipment to dig out dirt, reprofile the channel, and the expense associated with that. And lastly, it was a project we did for Virginia DOT summer of last year. This was, again, a roadside ditch. 8,600 square foot was used for this V ditch located along the highway. This was a demonstration project for the VDOT, and they were very happy with it and are planning some more projects in the future based upon the performance of this pilot project. So in short, we have drop-in specifications. We have typical detailed drawings in both Adobe and AutoCAD. We have installation guides for various types of installation applications. Again, slope protection, canals, berms, culverts, lots of videos and how-tos on our YouTube channel, and literally, dozens and dozens of case histories on our website as well. And that's what I've got for you today. It looks like we've got about 5 or 10 minutes left for any questions.
We do. So I'm gonna go back. In fact, I'm gonna take over the screen because I want to go back to something. On the specifications, one of the things, and you get a drink there, buddy boy. one of the things I like to remind our engineers of is you don't have to memorize all these ASTM standards. You don't have to memorize all this. We've got technical support right here with Nathan, and the specification matters because of what you said earlier. Lookalikes do not compare alike, and we talk often about Me Too products, but I think the specifications is huge in protecting the integrity and success of the project. So then that immediately goes to the perceived quality of the engineering service, the design recommendations of the engineer. So we care a lot about specifications. In fact, some of my business cards in the past said specifications engineer, but I'm not creating those specs. I'm just relaying those specs. But Nathan, you said something early on about those ASTM tests that for some of those, like the 8364, you're the only one that meets and exceeds every category in that ASTM requirement.
That's right. Yes.
So the other products might say they're the same. They might say they look alike, but they cannot satisfy that 8364. So that's how an engineer would protect themselves. If they didn't want to say brand name concrete canvas, they just wanted to say a generic term. I think they still got to honor that specification, right?
That's right. Yeah, you don't have to say concrete canvas. If you have a situation like that, you can just say a GCCM meeting all requirements of 8364.
And I like that you said you were on site sometimes to help teach a contractor how to put this in. We've all seen it when you have a contractor who's new to something and it's new to them. It might not be new to their market even, but if it's new to them, there's a little bit of fear involved. And they want to pad their number maybe for the installation, but you want to be there to make sure that it's done right. And do you see what I see, where once they get started, it's almost like they don't need you. Their confidence grows quickly once they get comfortable with how to do it right?
Absolutely. We were doing a project for Georgia Power a couple of weeks ago, and it was a slope that was 300 foot wide. It was 50 foot deep. It was a fairly steep slope. Yeah. So we got, I think, 3 panels installed before lunch that morning. But the next day they had, I think, 7 panels installed before lunch, and ended up with 20 panels a day for the third day. So there's a little bit of a learning curve, getting comfortable with it, how do you lay it out? How's the best way to do it? And every site's going to be a little bit different. But yeah, it's certainly every job that I've ever been on, the people have been surprised at how easy it is by, again, the second or third day. And they realize, it's really not that hard
One of
to
my
install it.
one of my guys in Colorado was supposed to send us pictures, and he did. And I can tell you that the contractor that took him out to a site for the first one they did showed him 11 projects, and he became a champion for it. So he went from being a skeptic to now he's a champion, and he's the DOT or the cities, the county, whoever, the owners, the private developers, they have a great comfort level with that contractor. He went from being not sure to an expert.
Right.
So about a half hour ago, we got asked a question from Dennis Bull. Can the GCCM be installed around the perimeter of a lake? You've answered this with part below the water line, and will it cure underwater? You even answered it'll cure even in salt water.
Yeah, actually, we've got a couple of applications on our website where it's been used for boat docks.
All right.
So where they just install the whole thing underwater and it stayed underwater.
That's
so
awesome.
yes.
And then Forrest asked, does it come in small panel applications? You answered that about tight access, and he sees an opportunity for bioretention inlets where it can be used as armoring for an inlet. If it's reasonable to score the surface to create dissipation for entering water, I think you answered it better. I think it was Colorado DOT where they put a sandbag or something underneath, and they formed it with a berm built in to slow that water and create a forebay and kind of back off that velocity.
Right.
I answered that. I should let you answer it. People want to hear your voice. They hear me talk all the time. What would you add to that for small panels, for smaller applications?
Yeah, so we do have batch rolls for the type 1 and the type 2. The batch rolls for type 1, they're 108 square foot, so they're 33 foot by 3. They're 33 foot by 3 1/3 foot. So
okay.
The rolls are pretty small as far as area wise, but again, they're 2 people can transport them fairly easily. The type 2 rolls, I believe those rolls are more like 54 foot by 3 foot. So I'm sorry, not 54. I'm 54 square foot.
Okay.
So those rolls are a little bit short. I think they're 17 foot long versus 33 foot long for the type 1.
And you mentioned that the one roll was maybe 150 pounds, so 2 people could walk it into a tight access spot.
Yes.
So I'm gonna say we answered that one live too. You mentioned the water rule of thumb, and I didn't move fast enough to write that down. You talked about pounds of water. What is that general water rule of thumb?
So for the CCX, I'm sorry, for the concrete canvas version, it's 40% of the weight.
Okay.
So if the type 1 weighs, let's just say 1.6 pounds per square foot, then that would be 0.65 pounds of water.
Okay.
And if a gallon of water weighs 0.83 pounds, then a gallon of water is going to get you about 13 square foot hydrated, something like that.
All right.
And then for the CCX, those rolls are more like 4 pounds a square foot. So the water requirement there is half of the weight. Yes.
All right. Well, I think that's good. And my friend Don, he's on here every time, and Donald likes to play stump the chump, so he always asks the hard questions. He said, "How do you screw at 4-inch centers if you're installing underwater? Do you typically dewater a project, or can you assemble panels and pull them into the water?" How would you answer my friend Donald?
Yeah, or unless you had a waterproof drill, I mean, I guess you could do that too. But no, yeah. For the boat ramp access, they did screw it together onshore and drug it into the water. And the screws aren't magical. So if it is underwater, I mean, you could use some sort of geotextile nail every 4 inches or something like that. I mean, it doesn't have to necessarily be as a regular screw. It could be something to join those together on 4-inch centers. It's just that with the amount of screws that you normally need, you want something cheap and small and easy.
Yeah, and the engineer in me wants to do everything. I want to overdo everything. I want to seal it, screw it, thermal bond it. I want to just do all the things, and it's just not all that necessary. Like you said, maybe 5% of projects actually do thermal bonding, and I know all of our branches have sealant. We provide sealant for this and other type of products, so it's readily available. The seals are readily available, screws are readily available, stainless steel screws are everywhere. It's pretty easy.
And sealant can also be problematic in some instances, because if you do have high hydrostatic pressures or high groundwater pressure, then not using the sealant allows that pressure to bubble through those seams. But if
Smart,
you have them sealed off, then it's going to push it up and it could crack and damage it. So
smart.
if you are going to use sealant, make sure that's not a problem.
Yeah, and you even said that about, oh, there's my timer. You even said about some projects that you actually build in and design in some drainage, whether it be a perforated drainage tile, a rock layer, both. Some projects you
Right.
want to relieve that hydrostatic pressure. If we're taking the place of one of those plastic ditch liners, in that case, on a small ditch, we don't want the water going under it. We want to contour to the ground and show what you showed, where it keeps the water up on the top of the protection. So that's where it helps to have someone like you involved up front to give that best recommendation to give us the best chance of success.
Right.
Yeah, well, you're a gentleman and a scholar, so I appreciate you. With that, I think we're good on time. Any parting words, Nathan? I know we talked before, like what are some things you want to leave people with? We talked about compressive strength and abrasion resistance and flexural strength. Those are the difference makers between you and Me Too products, correct?
Yeah, 8364 is far and away the most important thing to remember. Remember that you specify a product that meets those requirements. Like I said, I've been with Agro and GSE for going on 30 years, and Concrete Canvas has, I think, a much better technical library, resources for installation guides, for videos, for case histories. I just think we've done an incredible job and have an incredible technical library for people to go and look at, at their own pace, whatever interests them, specific questions they may have. So
Perfect.
yeah, don't hesitate to look or ask me if you have any more questions, but certainly, look on your own and see what you can find.
And they can reach out to us if they want to do a lunch and learn and have you join virtually like you did here. So Nathan, if you'll
For
let
sure.
me, I'm going to end with a couple things taking care of business for us. My buddy Tyler Searle is joining us next month for Muscle Wall. This particular project on the left is out in Colorado, but he's got some awesome case studies to share with us. And I'm very excited to tell everybody Clean and Green's coming back. So Clean and Green's going to be, here's the dates where we're going to be in Salt Lake City, Denver, Columbia, Missouri, Wichita, Kansas, repeat in Omaha again. And then instead of Des Moines, we're doing Coralville, Iowa City in March. So if you look at those dates, use this QR code. I'll back up one step. So go ahead, use your phone, get this QR code, register for Clean and Green. If you register before January, you can get be eligible for a $100 gift card. Here's a QR code as well, unless you have the participants in the way like I do. This is for next month's webinar. So Nathan, thanks a lot for joining us, buddy. I think you did an awesome job. Outstanding. Any parting words to say goodbye?
No, I just want to say thanks everybody for your attention and for the questions, and don't hesitate to reach out to us if you have any more questions or need us to do a site visit or help you with the spec or detailed drawings or whatever it might be.
Fantastic. Thank you. I appreciate you, buddy. Have a good day.